Dr. P.R. Krishnaveni, Associate Professor of Chemistry, Sasi Institute of Technology and Engineering, Tadapalligudem. Welcome to the lecture on BET, Graphene and Fullerenes. BET. BET means Brunner-Emmett-Teller method. So it is a gas adsorption and nitrogen absorption method, and this was introduced by Stephen Brunner, Paul Hugh Emmett and Edward Teller. This directly measures the surface area and pore distribution. So coming to the classification of the pore, pores are classified as micropore, mesopore, macropore, depending upon the size of the pore. Micropore means the size of the pore will be from 0.1 to 1 nanometer. Mesopore means 1 nanometer to 10 nanometers. Macropore means from 10 nanometers to 1000 micrometers. So this is how we will be recording the BET. So here we have to insert sample into cell and we have to degas the sample to remove excess of moisture on surface. So coming to the large surface area samples. Large surface area samples will adsorb or dissolve more nitrogen. So this is the sample which has small surface area. As small surface area samples will absorb small. So that's why here if we observe the absorption or desorption, they are absorbing less. And coming to the large surface area samples, they will absorb more amount of nitrogen or they will dissolve more amount of nitrogen. So more amount of nitrogen, no, so that's why it is showing like this. Similarly, it dissolves also more amount of nitrogen. So this is the schematic diagram for BET equipment. So this is the sample amount we are taking, and here we are getting the analysis result, and this is the termination, and this is the run time. So here where these two will be plotted. This you can see here. This is how we are presenting the data. So the amount of nitrogen absorbed will be plotted against this. So this is the sample SiO2 what we have taken, and this is the surface area of that sample, and this is the pore size. And for this sample, this is the surface area and this is the size of the pore. And coming to the second topic here, graphene. Graphene was discovered by Russian-born scientists Andrei Jim Kostya Novoselov at the University of Manchester in 2004. They have won the Nobel Prize in 2010 for this discovery. And graphene is a one atom thick planar sheet of sp2 bonded carbon atoms that are densely packed in honeycomb crystal lattice. So here all the carbon atoms are sp2 hybridized carbon atoms. And this graphene is the basis for C60 fullerene, which is called as Buckminster fullerene, nanotubes and graphite. And coming to the distribution of electrons in graphene. So it contains 6p orbitals and the carbon atoms are sp2 hybridized carbon atoms. So how we will show this overlapping means delocalization. So the delocalized electron cloud. Here we are observing a delocalized pi electron cloud. Above and below the plane. That means the electrons are free to move along this delocalized orbitals across the plane. That is the reason why graphene and graphite are great conductors across plane. Coming to the properties of graphene. Graphene has high thermal conductivity, high electrical conductivity. Here the electrical conductivity, how we can explain means graphene electrons these graphene electrons behave like photons in mobility. Why means due to lack of effective electron and hole mass. And not only that, graphene can travel through short distances without scattering. That's why graphene has high electrical conductivity. Next property is it has high elasticity and flexibility. Graphene is the hardest material. It has high resistance. That means graphene is 200 times stronger than steel. That means similar to diamond but much lighter. Ionization radiation is not affected by graphene. And graphene generates electricity by exposure to sunlight. And as graphene is the thinnest material, we can not only thinnest material, it is also a transparent material. Graphene has high density. As it has high density, it does not allow helium to pass through it, but allow water to pass. And it shows antibacterial effect. That means bacteria cannot be grown on graphene. So these are some of the properties of graphene. And coming to the applications. So coming to energy applications. As graphene is the thinnest material, and has high surface area, to volume ratio. That is the reason why graphene can be used as a promising material in batteries and supercapacitors. Graphene can also be used to enhance fuel cells. As earlier I told you in the properties, graphene can produce electricity using sunlight. So graphene can be used in solar cells. Next, coming to the application sensor, biosensor and heat sink. As in thermal properties, what I have said, first property is graphene has high thermal conductivity. That's why it can be used in heat sink. Heat sink means a device or material that absorb unwanted or excess heat. And as the graphene is the thinnest material and it is the strongest material, graphene enhanced composites, they find applications in aerospace, in building materials, and also in mobile devices. It also finds applications in electronic devices, especially in microelectronics. Example, they can be used in making LED bulbs. And these LED bulbs will produce more light and long lasting. And not only that, they are also used in mobile devices, especially in making thermal foils, which will dissipate the excessive heat. And coming to the environmental applications, graphene is used in desalination technologies as well as in environment treatment and protection. And coming to the biomedical applications, as graphene is thin and flexible, it finds applications in bionics. Bionics means a mix of biology and electronics. That means a device which is used to implant into a living tissue. So that's why it is used in diagnostic technology, drug delivery, therapy technology, scaffold materials. It is also used in artificial hearts, and it also used in cochlear devices which will assist the people with loss of hearing. So these are the some of the applications of graphene. Coming to the third topic, fullerenes. Fullerenes belong to carbon family and it is the third allotrope of carbon. Fullerene are molecules composed entirely of carbon with spherical, ellipsoid, tubular or combination shape. Spherical means buckyballs, tubular means in the form of nanotubes, and a combinational shape means like nanobuds. They consist of hexagonal and pentagonal rings with the latter necessary for the curvature of the molecule. The most common is C60 fullerene, named as buckyball or Buckminster fullerene, and the smallest one is C20 fullerene. So coming to the C60 fullerene, this C60 fullerene consists of 12 pentagon rings and 20 hexagon rings. And each carbon atom is a member of one pentagon ring and two hexagon rings, as well as each carbon consists of two single bonds and one double bond. And these C60 fullerenes, not only C60 fullerenes like C70, C80 and C90 are also possible. This indicates the number of carbon atoms in the fullerene. Coming to the applications of fullerenes. Fullerenes are used in the medical field as light activated antimicrobial agents. They are also used in several biomedical applications, including the design of high performance MRI contrast agents, X-ray imaging contrast agents, photodynamic therapy and drug and gene delivery. Buckminster fullerene is used in drug delivery systems, in lubricants and as a catalyst. It is also used as a conductor. Some types of fullerenes can be used as an adsorbent for gases. It is used in making cosmetic products also. C60 based films are used for photovoltaic applications. Fullerenes are also used in making carbon nanotubes based fibers and fabrics. So this is the overview of the applications of the fullerenes. So this shows what? Fullerenes can be used as gas storage, separation, and it can also be used in diagnostic agents as cosmetics. It is also used in lithium ion batteries, solar cells and fuel cells. Why means fullerenes are nothing but what? They are obtained from graphene only. So what are the applications are there? Graphene. Most of the applications will also come under fullerene applications. They can be used as catalyst polymer additives. Fullerenes can be used in sensors, photolithography, and they are also used in water purification. Thank you.